And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. Today's problem is n queen problem, which is marked as a hard level problem and is a very common interview problem as well. Let's see what we will be given into this problem and what we have to do. So we will be given just one parameter n of integer type and its n value can range from 1 to 10. Okay, 1 to 10 can be the value of n. And what we have to do, so basically we have to create a n by n matrix, n by n chessboard, and we have to place n queens in them such that they cannot attack each other. Okay, all right, I think it's a too bit of explanation, so let's quickly see it with one example as well. So this is, let's suppose n is equal to 3. N is equal to 3. So we will create a chessboard of 3 by 3, something like this. Okay, so this is my chessboard. And now what we have to do, we have to basically place 3 coins in this chessboard such that they cannot attack each other. Okay, so how can the queens attack? So if you have played chess, you know ki, look here, if we are placing some queen here at this point, let's suppose there is a queen, so that queen can kill all other queens in this direction, that queen can all kill all queens in this direction, and it can also kill all queens in this direction and also in this direction. So basically in both diagonals and we in both rows and columns, in the row and column and in both diagonal, we cannot place any other queen because it will kill that queen. Okay, so now this is what we have to do. If let's suppose take any other example, let's suppose my queen is at this point. So this row we cannot place any other queen, this row we cannot place any other queen, this row, which row, yeah, this row also we cannot place, and this row also, this in this diagonal also we cannot place. So where we can place after placing first diagonal here, you can see only these two places are there. Okay, so now let's suppose I fill at this point. Now again same thing, in this row we cannot place, this column we cannot place, this diagonal, and in this way there are various many restrictions where we cannot place, and we have to return the row numbers where we can place them. So basically let's quickly see one happy case as well, with let's suppose 4 by 4, something like this. Something like this. Okay, all right, so what is the happy case? For n is equal to 4, we have to basically put 4 queens in this chessboard such that they cannot attack each other. Okay, let's suppose I fill first queen here. Okay, first queen I filled here. Okay, second queen, where I can fill, can I fill it here? No, I cannot fill it. Okay, why? Because diagonal is there. Okay, can I fill it, can I fill it at this point? No, we cannot fill because they are in the same column. Okay, can I fill it at this point? No, I cannot fill it here as well because diagonal. So, can I fill it at this point? Yes, I can fill it because it is not overlapping with any of the diagonals and any of the row or column. Okay, all right. Two and are done. Third queen, where we have to place, I can place third queen here. Why? Because look, it's not collapsing, it's not being attacked by any other queen for now. So these are the things, and nothing is colliding for now, so it's okay. I can place my coin here, and after that can I so look, in only one row one queen can be placed. So I will move to second, third, fourth row, final row. Can I place it here? No, we cannot place it here. Can I place it here? No, we cannot place it here. Can I place it here? Yes, I can place it. So the fourth queen, where I will place it here. Okay, all right, so this is one correct answer ki we can place 4 queens. Now what we have to return, what we have to return is basically array list of array lists. So there can be multiple possible answers, there can be multiple possible answers. So we will return one master list, one parent list, in which there will be some small lists, let's say children lists, which are containing one solution of n queen puzzle. So for this, what is the one solution? First one is basically second, what I was saying. second column in the first row. Okay, I will fill 2. After that, fourth column in the second row, let's write fourth. After that, first column in the third row, okay, I will write 1. And after that, third column. So this is one of the answer, 2413. In this way, there can be multiple answers and I will fill them all in my answer array list and we will simply return it. So this is what we have to do. I think it will be very, very clear to you with such a deep explanation. So here you can see for n is equal to 4, there are two answers. First one is 2413 and another one is 3142. Okay. So yeah, in this way we have to fill these endpoints and get our answer. Okay, all right. Let's quickly move to one note where we will understand how we can get the solution of it. I am expecting the problem statement will be very, very clear. We just will be given one n of integer type, which means it's a n by n chessboard. Chessboard is of size n by n, and we have to place n queens. We have to place n queens such that no queen can attack each other, and we have to return the column position for each row in the array list. Okay, all right. I hope I've again um, told this so it will be clear. Now let's quickly move to one note. So how are we going to approach it? Look, there is no rocket science for it. There is no any algorithm for it. One algorithm which is there is basically to try all the cases, try all the positions. Okay, all right. How we are going to position them? Look, the solution which I will be telling you is will be the most smallest solution possible. Okay, so I am thinking, I hope so. I can be wrong as well. And it will be the easiest one. Okay, all right. So what I will do, let me take a pencil, draw. So let's suppose this is my answer array list which we will return, in which there will be small lists as well. Okay, all right. So now look what is there. Key, suppose if I am filling any queen at this point, it means we cannot fill it in any other columns. Like this is now blocked, this is now blocked, this is what, this is a column. Okay, so I will make one column array of n size. Column array is of n size. Okay, all right. Now row, basically if I fill one queen at this point, I will move to the next row. We will move to the next row only, so no need to track rows because it will be already tracked. Because if I'm filling one queen at any point, I'm moving to the next row. Now I'm moving to the next row. Okay, but I have to keep in count two diagonals as well. First one is this diagonal and second one is this diagonal. So we can name it one as normal diagonal, right diagonal, whatever you want. So how many diagonals will be there? How many diagonals will be there? Let's quickly see. If I will select this, um, how we can select it here. I will fast track this so that it does not take time. I don't know how. Okay, all right. It's deleted. So this is my okay, all right. So how many diagonals can be? First diagonal is this, second diagonal is this, third diagonal is this, fourth diagonal is this, fifth diagonal is this, sixth is this, and seventh is this one. Okay, how many diagonals are there? Total 7. Okay, 7 for n. 7 for n is equal to 4. 4 rows, 7 columns. So 3 rows, what will be? It will be 5 columns. For 3 rows, let's say about n is equal to 3. So for 3 by 3 chessboard, there will be 5 columns. How? Let's see. First one is this column, second one is this, third one is this, fourth one is this, and fifth one is this. Okay, 5 columns. So can you see any formula making here? Yes. Total number of columns for any square matrix will be 2 into n minus 1. 2 into n minus 1. So basically I will have to make two more arrays. I have to make two more arrays. Let me quickly delete all these things. First one is, let's suppose, normal diagonal, which will be moving something like this. Okay, normal diagonal of length 2 into n minus 1. And similarly, one right diagonal. Right diagonal is basically something like this, okay, which is right diagonal. I hope it everything is clear till this point as well. Right diagonal is also same. Okay, all right. Now what I'm going to do is very interesting. What I will do, suppose I'm feeling, look, I don't know how many solution can be, what possible solution can be, so I'm going to follow all the uh, possible cases. I'm going to follow all the possible cases. Okay, all right. Okay, so first of all, what I will do, I will fill first coin at this point. I will fill first coin at this point. Okay, on filling first coin at this point, what I will do, I will basically mark my column of 0 is equal to true. Column of 0 is equal to true. Basically, four columns are there, so first one is true. It means कि first column is filled. It means first column is filled. Okay, all right. Now we have n diagonal as well. So which diagonal is this? For normal diagonal, if I am at any coin, let's suppose I am at putting this coin or I am putting at this coin. So what will be the diagonal for this? It will be equal to I plus j. It will be equal to I plus j. I plus j basically means at which column I am and at which row I am. Okay. So what will be the values? Let me quickly tell you. Uh, if I talk about this, something like this. Okay. The possible diagonal values will be row plus column here is 0, row plus column here is 1, row plus column here is 2, and row plus column here is 3. Basically means कि look, row plus column. Okay, and after that, I think I am written something wrong. It will be something like here. Row plus column is equal to 1, row plus column is equal to 2, row plus column is equal to 2, 3. Okay. And here at this point, what will be the rows and columns? Rows at third rows are become 3 and column is become 2. Column is 1, so it will be 4, it will be 5, and it will be 6. Okay, something like this. Of length 7, 2 into n minus 1, 7. Okay, all right. So basically, if at any point I am filling at this, I'm filling at, let's suppose here, I'm filling at here. Okay, so which column, which row, which end diagonal I will mark as true? This total row is 2 and total column is also 2. Total column is 1. This is the first column, like 0 index, 1 index. This is the second row. So third diagonal, in end diagonal, I will mark the third index as true. It means it is taken and we cannot fill anything more. Okay, I hope this point is very, very clear. I just did a little bit fumble, but now end diagonal is done. Let's talk about R diagonal. So for R diagonal, we will simply do row minus column. We will simply do row minus column. Okay, so what will be the row minus column? For this, row is 0. Okay, row for row is 0 and column is what? Column is third. Okay, so it will be minus 3, it will be minus 2, it will be minus 1, it will be 0, 1, 2, 3. Okay, all right. These are the right diagonals. Okay, so let's suppose if anyone has filled at this point, if anyone has filled at this point, what I will fill in the right diagonal, which index I will populate, it will be number of rows here. Total row is third, and minus column is what? Column is 1, which is equal to 2. So second row in and right diagonal, I will populate the second index, basically 0, 1, 2, in this way. Second index as true, it means it is taken and we cannot fill any one more here. Okay, all right. So, but here you can see, if let's suppose minus 1 can also be the case, minus 2 can also be the case, minus 3 can also be the case. So what I will do? Basically, minus 1, minus 2, I cannot locate them in the right diagonal. Isn't this correct? It is, we cannot locate them. So what I will do, I will basically do plus n at each index. Plus n, plus n. Okay, so minus 3 plus 4, minus 2 plus 4, minus 1 plus 4, and 0. 1 plus 4, 2, and 3. In this way, we will have some correct numbers which I will mark in the right diagonal as true. Okay. All right. So now I got columns, I got n diagonal, I got right diagonal as well. So if this is, let's suppose for any point, let's suppose I'm filling at this point. So what I will do, I will simply check if this second column is empty or not from this. Okay. If this diagonal, right diagonal is empty for this, what will be the right diagonal index for this? 1 is the, yeah, 1 is the row and 2 is the column. So 1 minus 2 is basically equal to minus 1. So this is the row. This is the row for it, minus 1. Okay. And minus 1 plus n equal to anything which you can think, 1, 2, 3, 3. So I will check the third index. In this way we are going to do, and if all are empty, we will mark all of them as true. Basically means column is also taken, uh, right diagonal and normal diagonals are also taken, and we will simply move forward. And after coming back, we will backtrack. Okay, so in this way we are going to do this. I hope it will be very, very clear to you now. The approach will be very clear, but when I'm going to write the code, the whole problem will become crystal clear to you. Let me quickly explain this once again. Let's delete all these things and we'll copy this again, something like this. So what I will do, I have columns. I have columns. 4 columns is there, 0, 1, 2, 3. 4 also, let's suppose one index we are considering. After that, n, these are the columns. Normal diagonal, 7. This will be this only. 4 length. Okay. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Something like this. I think I have added one more index. So 7 length and diagonal and 7 length right diagonal as well. Okay. Something like this. Okay, all right, very, very good till this point. What I will do, I will simply start for the first row. I will currently at the first row. I will start filling from this here. So let's suppose I'm filling at this. Okay, when I'm filling at this q, what I will mark, I will mark the first column as true, which means first column is taken, which means first column is taken. Okay, after that I will mark n diagonal, which is equal to row plus column at this point, which is both 0. So I will mark the first row as taken. Okay, first normal diagonal as taken as well. And after that, row minus column plus n, row minus column plus n is what, right diagonal, which is also equal to row plus column, here is 0. So it will be something like, I think fourth, 1, 2, 3, 4, 5, 6, 7. So this will be marked as true, this which means this is also taken, which means this is also taken. Okay, all right. Now what I will do, suppose at any point if I have filled, at any point if I have filled one row, so what I will do, I will simply move to the next row now. Okay, so I will again check, can I fill at this point? Can I fill at this point? No, because column of this is empty, which is true. Okay, all right. So I will move further. I will check, can I fill at this point? Okay, column of second column, which means first index is empty, yes. And diagonal is also empty. Okay, which is basically equal to row plus column. Right diagonal is filled. Right diagonal is also fourth one, this one, so this is filled. No, we cannot fill it here as well. Okay, I will come back. Now I will try to fill at this point. Can I fill at this point? Yes, we can fill. So I will fill at this point and I will mark the respective column and row diagonals, normal diagonals as true. Okay. Then I will move again to this here. Can I, okay. So when I'm filling at this point, which I can, what I will mark as true, let's see. This is taken, this is taken, and this is taken. Okay. Now I move to here. In the third column, I move to here. Can I fill queen here? No, I cannot fill because this column is filled. Can I fill here? No, because this diagonal is filled. Can I fill here? No, it's already taken. Can I fill it here? No, it's already taken. So in this row we cannot fill any queen, but we have to fill in each row, we have to fill one queen. So this position is wrong. I will backtrack. So again there was a loop, so now I will try to fill at this point. Now suppose I filled at this point, again same number of columns rows will be marked, and again I will come back, and let's suppose for this also nothing is working. So now this queen is the last one, so on backtracking from here I will move to the before row. So now q instead of this, because it means when I'm filling queen at this point, I cannot get any solution, so I will move to this queen here. Okay, again I will keep on filling. Let's suppose I fill at this queue, so this will be blocked, and in this way we will keep on moving forward, and at last I will get my answer which we have to return. Okay, I hope the approach is also crystal clear to you, but when I'm going to write the solution, everything will be sorted. Okay, all right, let's quickly move on to the solution part then. But before that, if you have loved the explanation till this point, please subscribe the channel and like the video, because I'm making this video at midnight and I want your support, and it will really motivate me a lot. So please, if you have loved the approach, please subscribe and like the video. Okay, all right, now as I told, few arrays I will make. First one is the column, which is equal to new boolean of n length. Sorted it till this point. Now there will be two diagonals. First one is, let's suppose, n diagonal, new boolean of length what? If you remember, 2 into n minus 1. Okay, and after that what I will do, r diagonal. I don't know how long this video is, but this video deserves to be a long explanation because it's very common interview problem and very tricky as well. But with this approach which I am saying, if you will solve, it will be very clear. Okay, all right, now what I will do, I have to make one array list answer which I will be returning at the last. Let's suppose result is equal to new array list. Okay, and after that, look, for this small individual list also I have to make a list. Okay, so for that, let's suppose my list is tmp, temporary, which at last will be added into result, which is equal to also new array list, something like this. Now I will call a recursive function. Okay, let's suppose its name is solve, and I will pass few things. First one is n. Basically n will be needed to check what are the rows. Currently I'm at 0 row. Okay, and my column array, my n diagonal array, my r diagonal array, and my result, and my tmp list as well. Okay, so all these things I will be passing. Now let's move on to this solve function. Static, I will not return anything. Function name is solve. It will expect first thing as int n, next thing is row, current row. Okay, and after that n diagonal, after that boolean column, after that boolean n diagonal, after that boolean r diagonal, and after that one result, and after that one more is there, this is tmp, which is my current list as well, something like this. Okay, all right, so now there are a lot of parameters I expect, but these are reasonable as well. Okay, now at any point if my row is equal to n, it means 0 row is filled, 1 row is filled, 2 row is filled, 3 row is filled, and now fourth, I'm at fourth row for n. So it means all the rows are filled, and now I have got one of the ways to fill n coins. Okay, so that way will be added in my tmp. So I will just add something like result dot add new array list of tmp, something like this, and return. It means if I come here, it means all the rows are filled, all the rows are filled with n queens. So we have got one combination. Okay, all right. But if we have not got our combination, what I will do, I have to fill for my current row. I have to fill for my current row. Row, it will be current r. It will be not row, it will be current r. Okay, all right. Now let's suppose I am at this. I am at this row. My row is equal to my current row is equal to 1. So what I will do, I will start for each column of this row to check if I can fill, because look, row is constant. So I will traverse over all the column to reach at these points to check if these are already filled or we can fill something like that. Okay. All right. Let me quickly remove this. So what I will do, I will just write for int I is equal to 0, I is less than n, I plus plus, something like this. And now I have to check if, look, my current row and current column is this I. I have to check if these are filled at any point or not. So basically first one is what? This column I is equal to false, which means this is not filled, column I is not filled, and diagonal is also should not be filled. So n diagonal for current row and I as column will be what? Sum of them. Current row plus I uh, is equal to false. And one more thing is what? R diagonal. R diagonal also we have to check. So R diagonal will be equal to, for R diagonal index will be what? Current row minus column plus n minus 1. N is basically total number of way, because if you remember, I told you there were few diagonals which were coming as negative for current row minus I. So I've just added n minus 1 to it. Okay. All right. I hope this is clear. So coming forward, if we have come to 65 line, it means we can fill at I is equal to 0 and current row. We can place a queen at current row and I as column. Okay. So what I will do, I have to add to my TMP, like this is the column number which I can fill. I will simply do tmp dot add I plus 1. Okay. Now I have to mark these as well. So column I is equal to true, and diagonal is also equal to true, and R diagonal of this is also equal to true. Guys, I think I have explained this in very detail and it will be very clear to you as well. Now what I will do, I will move to the next row. How I'm going to move to next row? Very easy it is. N is constant. Now current row will be next row. So current row plus 1. Okay. And after that, col and n diagonal, R diagonal are all constant. Constant basically means same. What I'm writing, something like this. Okay, all right. Now after solving this, it means if either way it is correct or not, for this at any index where I have placed queen, we are done. So I will remove it from there and make it, mark it as at next column. That is what is backtracking. Okay, so I will simply add it. Now instead of setting them as true, I will set them as false, which means now I have to try another condition. Doesn't matter if if at this index was successful or not. Okay, but instead of adding, now what I will do, I will simply remove the last field, which will be equal to tmp dot size minus 1. And that's it, guys. That's it. I think when I will come here, I will simply do return of my result. Result is the array list of array list. So this is a backtracking function which will try to check all the combinations possible. Let's quickly try to compile this. And I'm very tired explaining this at night. So please subscribe the channel. Okay, I think I have missed this is equal to false condition here. Let's try to compile this again. It's getting compiled clearly. Let's try to submit this. And please subscribe the channel, like the video, and sit with pen and paper to understand what issue, what things I am doing. And it might not be clear in the first attempt. So please sit with pen and paper, try to gather all the things. And that was it for today, yaar. I hope you have liked the explanation. I'm going to see you again tomorrow. Till then, keep on coding and bye.